this section, we are going to speak about continuity. I have divided this section into 3 parts. What is continuity? We have 2 types of continuity, continuity at a point and continuity on interval. A function f of x is said to be continuous if we satisfy 3 conditions. The first condition, limit when x goes to a from left should equal to limit when x goes to a from right, and that means the limit exists. The value of the function is defined and they must be equal. This can be also summarized in one statement. We could say f of x is said to be continuous at x equal to a if and only if limit when x goes to a from left equals to the value of the function at a equals to limit when x goes to a from right. Both conditions are okay. Now, looking in this graph, we can notice this is not continuous because when we go to 0 from left, the height is -1, while when we go to 0 from right, the height is +1. So there is a jump. This type of discontinuity, we call it jump discontinuity. For a way of answering this question, this is what we have. This is 0. Before 0, we have -1. After 0, it's a +1. So we could say here, first of all, what is the value of 0? That is undefined. There is no definition at 0. Exactly at 0, undefined. The second, when we have limit, when x goes to 0 from left of the function, if we go to 0 from left, it is -1, while limit when x goes to 0 from right of the function, it's +1. So here, the limit when x goes to 0 from left does not equal to limit when x goes to 0 from right, which means limit when x goes to 0 of the function does not exist. So we will say f of x is discontinuous because both f at 0 is undefined and limit when x goes to 0 does not exist. So of course we did not satisfy any condition, so it is discontinuous. If we look in this graph, the limit exists because when we go to at 2 from left or at 2 from right, we'll go to the same height, but still it's not defined at 2. That's why it is discontinuous. There is a hole. This type of discontinuity, we call it removable discontinuity. Anyway, for us, we need to find first what is the limit when x goes to 2 for the function, and that will be limit when x goes to 2 of x squared -4 divided by x cubed -8. As we said in our lecture of limits, we could do it by 2 different methods. One of them is factoring, which is x squared -2 squared and x cubed -2 cubed. So applying factoring binomials, difference of 2 squares, square root of the first minus square root of second, square root of the first plus square root of second. Here it will be first minus second, then first squared plus the first times second, which is x times 2, which is 2x, plus second squared, which is 4. 2 squared is 4. So x minus 2 is cancelled with x minus 2. You will get here 4 over 12, which is 1/3. So the limit exists. The first condition is satisfied for continuity, but the second condition, what is f at 2, it's undefined. So we will say f of x is discontinuous at x equal to 2 because f at 2 is undefined. Okay. The reason we call it removable discontinuity because we can iterate it. In this example here, it's actually example 3. It's the same as example number 2, but we redefine the function. So here, to discuss the continuity, we should say f at 2, it's equal to 1/3, which is defined. Then limit when x goes to 2 for the function f of x. Now I'll do it by the other method, just as a practice, which is using synthetic division, x squared minus 4 divided by x cubed minus 8. Here we are dividing by 2. The numerator, I have the coefficient of x squared is 1, then coefficient of x is 0, and then constant is minus 4, so that will be 0. 1 plus 0, it's 1. 2 times 1, it's 2. 0 plus 2, it's 2. And 2 times 2, it's 4. So the remainder is 0. While dividing the denominator by 2, I have coefficient of x cubed is 1. Coefficient of x squared is 0. Coefficient of x is 0. Then minus 8. So that will be equal to 1 plus 0, it's 1. 2 times 1, it's 2. 0 plus 2, it's 2. 2 times 2, it's 4. 0 plus 4 is 4. And 2 times 4, it's 8. So that will be 0. So that will be limit when x goes to 2. If we divide the first one, we decrease the power 1 degree. So degree 2, it becomes degree 1. So it will be x plus 2. While here the degree was 3, so we decrease it 1 degree, so it will be x squared plus 2x plus 4. When you substitute, you will get 4 over 12, which is 1/3, so limit exists. The third condition, we need f at 2 must equal to the limit. And of course, that is obtained by condition 1 and 2. So we will say f of x is continuous at x equal to 2 because we satisfy the 3 conditions. Here is a similar question. Clearly, this function is continuous function. So let's do the same thing. What is f at 3? F at 3 means here is when x equal to 3, we need to replace it here. We have to say it's a 3 squared plus 12, and that is 9 plus 12, which is equal to 21. The second, limit when x goes to 3 for the function f of x, that's limit when x goes to 3, our function is x cubed minus x squared minus 18 divided by x minus 3. That will be limit when x goes to 3. Using synthetic division, we divide by 3. Coefficient of x cubed is 1. Coefficient of x squared is minus 1, but coefficient of x is 0, then minus 18. So that will be 0. 1 plus 0, it's 1. 3 times 1 is 3. Minus 1 plus 3, it's 2. 3 times 2, it's 6. 0 plus 6 is 6. And 3 times 6 is 18. And that will be 0. So the result of the division, when you divide by divisor, that will be the result of the division. Decreasing the power 1 degree, it will be x squared plus 2x plus 6. Now, replacing x by 3, you will get 9 plus 6 plus 6. So that will be again 21. So the third condition, f at 3 is equal to limit when x goes to 3 for the function. So we satisfy the 3 conditions. That's why we conclude f of x is continuous at x equal to 3. Now, example number 5, he wants me to discuss the continuity of the function in all real numbers from minus infinity up to plus infinity. Here I have 1 and I have 2. Before 1, it is x squared. Between 1 and 2, it's 1. After 2, it's 5. So what we need to say first, we need to say f of x is continuous on the interval minus infinity until 1, union from 1 to 2, union from 2 to infinity. We don't have any problem in each piece. We need to discuss it at each change. We have a few changes at 1 and at 2. So at x equal to 1, we need to find, do we satisfy the 3 conditions, which is if at 1? What is if at 1? If at 1, according to here, when x equal to 1, the value of the function is equal to 1, which is defined. Now, the second condition we need, limit when x goes to 1 from left. When x goes to 1 from left, we have it's x squared, so it will be 1 squared, which is 1. Limit when x goes to 1 from right. When x goes to 1 from right, my function is 1, so it will be again 1. So this means limit when x goes to 1 for the function f of x exists because they are equal. Now, of course, the third condition also satisfied if at 1 equals to limit when x goes to 1 for the function. So since we satisfy the 3 condition, we could say f of x is continuous at x equal to 1. Now, what about at x equal to 2? We need to discuss the idea at x equal to 2. The first condition is what is f at 2? F at 2, it says it's equal to 5, so it's defined. Now, the second condition is the limit. Limit when x goes to 2 from left. When I go to 2 from left, my function is 1. But limit when x goes to 2 from right. 2 from right, the function is 5. So they are not equal. Limit when x goes to 2 from left does not equal to limit when x goes to 2 from right, which means f of x is discontinuous at x equal to 2 because limit when x goes to 2 for the function does not exist. Now, this will end up the first part, which is discussing the continuity of the function at a point. Thank you for listening.